stuff with exponents. So let's kind of pick up. Let's start by looking at our exponent worksheet. And I'm going to look at the first 4 problems. These were already assigned, so hopefully they're already done, but you may have had a question about them. Okay? Now, this one is probably the easiest for us because we talked specifically about this yesterday. Zach, you want to take your hood off? We talked about this specifically yesterday. Who remembers what the negative means? Makes it a fraction, so it'll be 1/9. Who remembers what an exponent like this means? That means the square root the square root of 1/9 cubed. So the square root of 1/9 cubed. What's the square root of 1/9? 1/3. And what is 1/3 cubed? 127. Very good. Now, this is kind of like that, except it's got a little bit more stuff going on. When you have a parentheses with an exponent outside of it, that exponent goes with everything. So this is going to be 16 to the 1/2 and x squared to the 1/2. That 1/2, it's not really distributive, but it's like distributive. It goes with both things. What does this mean, 16 to the 1/2? The square root of 16, which is 4. So this part's 4. What does this mean? The square root of x squared. What is the square root of x squared? X. So the answer to the problem is 4x. Now, notice right here, this is perfectly okay. To do it this way is absolutely fine. But if you look right here, what do these 2 exponents do to each other when you multiply them? They cancel each other out and leave you with just x, which is exactly what happened, right? It shouldn't be tricky, but it's always tricky. I put this on every test I give over this unit. Honors, academic, doesn't matter. This question goes on every test. What do you think the answer is? 5√2x. Now, first of all, there's no radical. Why is there no radical? Because there's no fractional exponent. Now, there is a negative exponent, but that doesn't make radicals. What do negative exponents do? Flip it over. So what's that going to look like? What'd you say? Like this? What do the rest of you think? That's wrong. It's the most common mistake. It's wrong. Harry, what do you think?
Do we separate it again? Like it's 1/2 to the 5th and 1/x to the 5th?
I would if this were in parentheses, but it's not. What is the exponent on the 2, you guys? 1. That stays 2. But this guy has a -5, so he goes to the bottom. So the answer is 2 over x to the 5th. That's the answer. Only the x goes to the denominator. Look at it. Does the negative exponent go on the 2? No. There are no parentheses. So what would this be? 3 over x to the 4th. What would that be? Now, don't get wild and crazy. What would this be?
1/2.
Now that is 1 over 2w squared. The whole shebang goes down this time. Why? Because it's in parentheses and the whole thing has the negative exponent. See the difference between these?
Why would it be 1 over 4w squared?
Well, I haven't finished it yet. That would be the final answer. Yes, indeed, Moses. That would be the final answer. That's this. What's this one? 1 over 3x cubed. Now that's in parentheses. You're going to cube it all. So that's going to be 1 over 27 x cubed. Perfect. That is different than this. What would this be? 3 over x cubed. Right? That's different than this one. Pay attention to where the parentheses are. Okay. Now let's look at our note sheets. Let's make a little more progress on our note sheets. The first thing, we're on page 25. And we are looking at our book, page 296, number 20. Okay. Problem number 20 on page, whatever that was, 296, says write the equation of the exponential function that has this table of values. Now, we did this yesterday. Exponential function. What's our format for that? Y equals, not just bx, not just e to the x. Y equals a times b to the x. What you're thinking of, Jamal, is absolutely right in terms of the BFFs. The general easiest one to graph, y equals e to the x. The general format is something times something to the x. That could be an e, but it doesn't have to be an e. Okay, does anybody remember how we did this yesterday? This is exactly what we did yesterday, except now they're giving me a whole table of values and not just a couple of points. Who remembers? Harry?
Put negative 5.8 in for y and 0 in for x.
What did Miss Ford tell you yesterday? No matter what, start with the point that has a 0. I promise you will always have one. Use it. So negative 5.8 equals A times B to the 0. That's X, that's Y. What's that tell you? That A equals negative 5.8? Because what's this? 1. So now we have Y equals negative 5.8 B to the X. Now what do we do?
Plug in another point.
We plug in another point. And before, yesterday, we only had one other point. But now you get to pick. Which one would be the very simplest one to use? So I'm going to use that one. But you can use any one you want. So negative 4.64 equals negative 5.8 b to the first. Now, what's b to the first? B. So to get b, I just need to divide. And I'll use my calculator, and hopefully that works out to be something not too bad. Oh, 0.8. So my equation is y equals what?
Negative 0.8, negative 5.8 times 0.8x.
Perfect. Everybody okay with that? Remember that from yesterday? Same thing, just written a little bit differently. In the book. Uh-oh. Same page, now we're doing number 22. Do you have a book? Look at problem 22. What did they do this time? They didn't give you a table, they gave you a picture. The directions are the same. Use this picture to write the equation of the exponential function. Okay.
I'm sorry, can you repeat that?
Use this picture to write the equation of the exponential function. So, I'm going to do exactly what I did over here. Which means what? Starting how? Understand this is your format, right? And you're going to plug in which point? 0, 3. And that's going to tell you basically what? A equals 3. So we have y equals 3 times b to the x. Now we'll plug in our other point. So 1.49 equals 3 times b to the 4th. How do I start? 1.49 divided by 3. Is 0.4967 divided by 3. Trey, what's going on out there?
We really can't get us stuff
world do I solve this? What do? I take the fourth root of both sides. I need to figure out what b is, so I'm going to take the fourth root of both sides. Now, on my calculator, I have the capability of doing that. Alright, so here's what I want you to do. Does everybody understand this is the goal? We're going to find the fourth root. So we have our calculators out. I want you to press 4. Type the number 4. That's because we're taking the fourth root. Then press your math button, which is the third button down in the left-hand column. As you look down all those options, do you see where it says the xth root? That's option 5. So click down there to option 5, and then type in 0.4967. And did you get 0.8395?
Yes.
Okay, we'll do another one in a minute. Let's write this answer. So the answer to this question is y equals 3 times 0.8395 to the x. Okay, now let's just practice using that button one more time. This is not on the note sheet, but let's just practice one more time using that button. Let's suppose we had the equation c to the 5th equals 18. How would we solve that? What would we have to do? Take the 5th root. So to take the 5th root on my calculator, I start by pressing 5. You got to do that first. Which root? The 5th root. Then math. Click down to option 5 and type in 18. So the 5th root is 1.7826. Is that what you got? Yep. So now you know how to take roots on your calculator if, you end up having to do that again. Okay? All right, now we're going to do number 2. We talked about yesterday that if we have an equation like this, you can tell me about this equation. What is this first, what's this number? Well, yeah, but we call it the, look at your notes from yesterday, what did we call that? That number was called the initial value. And then what did this guy tell us? First of all, if we're growing or decaying, and then how much we're growing or decaying by, right? So if this number is more than 1 plus whatever, that's my rate of growth. And if it's less than 1 minus whatever, that's my rate of decay. So I'm looking at problem 2A. Write an exponential function. So that's this. That has an initial value of 4 and increases 11% per day. I think you can do that. Y equals what? 4 times 1.11 to the x or to the t. It's days, so I'm going to say t for time, but it can be x. Nobody cares. Don't let the variable mess you up. It doesn't matter. Do you understand why that's 1.11?
Yeah.
Because we're growing 11% a day. How about b? What's b going to look like? There you go. How about the next one? Be careful. Not 0.1. 0.9. Because when you see a 0.9 there, that tells you decay, right? How much decay? 10%. Because how much less than 1 is 90? 10%. Remember that from yesterday? How about D? 20.8. 0.955. How did I get 0.955? From 100. Kids, this number tells you how much more than 1 or less than 1. We need to be 4.5 less than 100%. So what are we? 95.5%. And the last one. How about E? 0.58. Did you notice that in none of these parentheses is the actual percentage? To get these numbers, we either take 1 plus the percentage if it's growing, or we do 1 minus the percentage if it is shrinking. You will never use the actual percentage. You're either going to add it to 1 or you're going to subtract it from 1. Now you're going to do what mathematicians do. You're going to apply what you just learned. The population of Calcville was 123,000. It decreases 2.5% each year. What is its population in 2010? You're going to write an equation just like one of these that describes the population of Calcville. What is the initial value of Calcville? 123,000. Is that population going up or down? Down. So to find this number, you're going to take 1 minus the percentage. What's the percentage? It's 2.5. So if we take 100 minus, I'll say 100 minus 2.5, what do I get? 0.975.
You have to write it like that.
What?
You have to write it like that. So if you write it like 97.5, that's wrong.
That's wrong. It has to be as a decimal.
Okay.
Yes, good question, Ashley. To the next. So here's my equation for Calcville. What's the question want to know?
What's the population?
Okay. How do you think I'm going to figure that out?
I put it there.
I'm going to put a number right here, aren't I? What number am I going to put there? 10. 10. Why 10? When was the initial population? In 2000? Now I want to know 2010. So how many years have passed? 10 years. So I'm going to type into my calculator 123,000.975 to the 10. And I've got about 95,489 people. I don't want any confusion. Why did I round that off? Why didn't I leave decimals? Exactly. These are people. So we're going to round off to the nearest whole person. That just makes sense. Remember, this is not times 10. This is raised to the 10. Let's try the last one. This is the last one. Here we go. Let's see if we can do it. Can you do it? The population of Trigville was 9876. It increases 12% per year. Set it up for me.
Y equals 9876 times 1.12.
I'm going to use T for a moment, but yeah. Does everybody understand why we put the 9876 here? And why this is 1.12? Now, how many years are we waiting? 8? So we're going to go ahead and type into our calculator this. And don't hit any equals in there till the very end. So 9876 times 1.12 raised to the 8. Now I'll hit equals. And we have that many people. Anybody have a question about that? All right, let me give you one more. Oral. It's not on the paper. I'm going to oral it. Your pre-cal book, let's say it cost $72. Because it is so valuable, it's increasing in value 28% per year. What will be its value in 20 years? Because of course you'll keep it for 20 years. All right, figure it out. Let's see if we can come up with an answer. So your book started out $72. It's increasing 28% a year. You're going to keep it for 20 years. What will be its value? First of all, I want an equation. Y equals 72
times 1.2.
1.28. Everybody good with 1.28? And you raise that to the 20th power. Tell me what you got. What? 10,000? Whoa! Anybody match that? Yeah. Isn't that pretty awesome? Better keep that book.
I'll flip up going to 5 days.
What do you think?
All right, one more quick question and then I'll stop. What if, instead of being your pre-cal book, what if this had been your history book? And it goes down in value 28% per year. What would change in the equation if our book were going down in value 28%? This number would be different. What would it be? 0.72. Because if you are going down 28%, it would be 100 minus 28. So that would be a 0.72. And it'd be worth
So it's 10 cents.
That's about right. Okay? All right. For tomorrow, you've got 10 minutes. You can go ahead and get started. If you have something else you need to study for, I am fine with you using this 10 minutes that way. But we're not screwing around. So we're either doing our homework or we're studying. Okay? So you decide. Hurry up, Erica.